Hello everyone. This lesson might be a little bit longer than the last one. There's a few moving parts. It relies on some things that you guys have learned in prior lessons. So if sometimes I'm going a little bit fast, just hit pause, back up the video, play it again. Play the section that you're not quite catching. Okay, so here it goes. From prior lessons, you guys know when you have an exponent on an exponent, you multiply the exponents. So this would be 3 to the 5 times 2, or 3 to the 10. Whoops, 10. This would be 3 to the 4 times 3, which would be 3 to the 12. When you have an exponent on exponents, you multiply your exponents. Okay. This, you know, is square root of 25 is just 5. I'm just practicing with you guys to rewrite this a different way. This would be 25 raised to the 1/2 power. It's a square root, so remember your exponent is going to be a fraction. It's going to be a half. This 2 is showing up here in the denominator. Okay, and if you want to see it, I'll prove it to you. You know the square root of 25 is 5. Well, 25 raised to the 1/2 power is 5. Or 25 raised to the 1 divided by 2, whichever way you want to type it. It's a 5. Okay? So coming back to this, I'm just proving to you that this notation is the same thing as this. So here, that's x to the 1/2. This is inside the square root. The square root is worth a half. This is inside it. Back to this. When you have an exponent on an exponent, you multiply your exponents. So this would be x to the 3 times the half, which is x to the 3 over 2. Don't write it as 1/2. Leave it as an improper fraction, 3/2. Okay, it'll make a difference later. Okay. So this is saying, from what we did in the last lesson, 3 to what power is 3 to the 5th? Well, 3 to what power is 3 to the 5th? Well, that's 5. Notice what's happening is this cancels out this. When the base of the logarithm matches the base of what's inside, you just get that. That's one way to approach it. It's one way to think of it. This is just fine. 3 to what power is 3 to the 5th? Well, it's just 5. This, I'm going to rewrite this part of it. Log base 3 of 3 to the 1/3. This is saying, or asking, 3 to what power? It's 3 to the 1/3. 3 to what power is 3 to the 1/3? Well, it's just 1/3. Rewriting this, it's log base 3 of 9 raised to the 1/3. Now I'm going to rewrite that 9 just a little bit. That's saying log base 3 of 3 squared to the 1/3. And we said that when you have an exponent on an exponent, you multiply your exponents. So it's log base 3 of 3 2 times a third, or log base 3 of 3 to the 2/3. Rewriting it, 3 to what power is 3 to the 2/3? 2/3. Okay, that one's a little bit hard. Okay, let's try this one. It's log base 3 of 81 to the 1/3 power. Now 81, you should start to recognize. 81 is 3 times 3, which you know is 9, times 3 times 3, which you also know is 9. 9 times 9 is 81. So 3 times 3 times 3 times 3 is 81. That's log base 3 of 3 to the 4th raised to the 1/3. So that's going to be log base 3. Suppose I should erase this. 3 to the 4 times a third. Let's put this down. So that's log base 3 of 3. Multiply these fractions. 4 thirds. 3 to what power is 3 to the 4 thirds? Well, 4 thirds. So this equals 4 thirds. Okay. Sometimes when you get the easy ones, they seem hard. This is asking 6 to what power is 6? Well, what's the exponent on the 6? 1. So the answer is 1. Again, you could think of this as these are canceling out and leaving you whatever the exponent was. If you had log base 6 of 6 squared, that's 2, because these cancel out. Log base 6 of 6 to the 11th, these cancel out, and you get 11. Okay? Okay, this doesn't quite cancel out here as it's written. Log base 5. Now I'm going to think of this as having an exponent. You step aside. 5 to what power is 1 over 5? That's 5 to what power is 5 to the negative 1. This is worth 1/5. Okay? So that's 5 to the negative 1. The base is matching the base, so they cancel out. Or 5 to what power is 5 to the negative 1? Well, the answer is negative 1. Okay. If the base is missing, it's a 10. Okay. Just like this, what number is missing here? Well, it's a 2. That's the same thing as the square root of 25. The base is missing, it's a 10. So this question is asking 10 to what power is 1,000? Or 10 to what power is 10 cubed? Well, that's 3. Okay. Now this, ln, that's not the same as the logarithm. This is the same as log base e of 5. Okay, base e, what is this e thing? E is like pi. I mean, pi is a non-repeating, non-terminating decimal. If you go to your calculator, there's e. If I go second ln, there's e. If I do it to the first power, that's what e is worth. Okay? I know it kind of looks like it's repeating, but it's not. That's been rounded on the end. It's a non-repeating, non-terminating decimal. Okay? I'm just showing you what this translates to. There's nothing to do here. You're done. Okay? There's no more math to do. Reminding you, 6 to what power is 6 to the 5th? Or when the base of the logarithm matches the base of what's inside, they cancel out. So your answer is 5. The base of the logarithm is matching the base of what's inside, they cancel out. So the answer is 21. So when you get one like this, that's saying log base e of e to the 5th. The base of the log is matching the base of what's inside, so they cancel out. So the answer is just 5. It's not canceling out here because it doesn't have this e in it. Okay? These two questions are not the same question. They're different. That's as good as it gets. You're done. That is the answer. Okay? It doesn't simplify. This one does, because again, that's the same thing as log base e. That's this. Now this e to the 5th is still there. These cancel out and give you just 5. Okay? All right? I think that's it. If you guys have questions, be sure and let me know.